Today you will use key features of quadratics to graph those quadratic equations. The math practice you're going to use is use appropriate tools strategically. You're going to use this practice because there are a lot of tools, a lot of pieces of information that you've learned that we're going to put together today in this lesson. So for this section 4.2, the first thing that we need to make sure we have down is that this right here is the standard form for the quadratic equation. This is written as a function because it has this f of x, but that could either say f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. A, b, and c are bolded because those are the spots where we would put numbers in, and those are the numbers that we will use to find these key features. So first thing, make sure we really have a good understanding here. A parabola, that's the name for the U-shaped graph that quadratic equations create. So whenever we graph a quadratic equation, it always creates that U-shaped graph. Now a reminder that that is only up and down. So the U-shaped graph only is up and down. They're never side to side. All right, the axis of symmetry is a vertical line. Because it is only up and down, then the axis of symmetry is only going to go up and down as well. It's the vertical line that divides the parabola into two equal parts, or two equal halves. So if this is my parabola, my axis of symmetry is going to go right down the middle. And that was a really poor drawing. If this is my parabola, the axis of symmetry goes right down the middle. It breaks it up into two equal parts. Next I have vertex. Vertex is the point of the parabola that crosses the axis of symmetry. So I have the axis of symmetry, and then the vertex is the spot that crosses that. So it's the middle point of the parabola. We have one other word that kind of goes with these, and well, two words. We have a maximum and a minimum. So a maximum is the highest point, and the minimum would be a lowest point of the parabola. So if we have a parabola that looks like this, that's going to be the maximum. If we have a parabola that looks like that, that's going to be the maximum. It's always going to be the vertex, so it just depends on which way the parabola is facing for if it's a maximum or minimum. It's never going to have both. So those three things are grouped together because they're all related. We have the axis of symmetry, and then we have the vertex that's a point on the axis of symmetry, and then we have the maximum or the minimum that is actually the same point as the vertex. So how do we find this number? Well, we use negative b over 2a. When we use negative b over 2a, that gives us the x value for the vertex. It gives us the x value for the maximum or minimum, since those are points. It gives us where the axis of symmetry falls on the coordinate plane. All right, now moving on to the next set of words. We have y-intercepts. So the y-intercepts are the points where the parabola crosses the y-axis. For quadratic equations, there's only one y-intercept. There's always only going to be one y-intercept. So how do we find this number? Well, let's think about it. If it's the point where it crosses the y-axis, let's draw this over here. We have a graph, we have a parabola that crosses the y-axis. It's this point right here. Well, no matter where it is along the y-axis, x is always going to equal 0. So, to find this number, we're going to substitute 0 in for x and then solve. So when we substitute 0 in for x, that's going to give us the y value. So that tells us where it falls on the y-axis. Now looking at this equation right here, ax squared plus bx plus c, if I were to plug in 0 for x and 0 for x there, this is always going to come out to c. So the y-intercept will always be your c value. All right, the next one is x-intercepts. So we just talked about y-intercepts. Now the x-intercepts, that's the point or the points where the parabola crosses the x-axis. Now if we think back to the past couple days in class, we discovered that there can either be 0, 1, or 2 x-intercepts. No more, no less. So how do we find this one? Well, if for the y-intercept, if that's where x equals 0, so we substitute 0 for x, then the x-intercept over here on this graph, those are the x-intercepts. Those are where y equals 0. So we're going to substitute 0 for y, or for f of x if it is written in function notation, and we will solve. Now, this is a quadratic, so when we have 0 equals a quadratic, to solve, we will need to factor. And if it's not factorable, then we'll need to use the quadratic formula. Now, y-intercepts and x-intercepts are related, but the determinant is also related to x-intercepts. So if we think back to that discovery and reflection activity that we did in class, we should remember that the determinant, or as we called it, the determinator, is the number that determines how many x-intercepts a quadratic equation has. So thinking about how to find this number, this is where we had to use the b squared minus 4ac. And when we did that, if it was negative, then there were no x-intercepts. If it was 0, then there was 1 x-intercept. And then if it was positive, there were 2 x-intercepts. So why is this? Well, a lot of us discovered that b squared minus 4ac actually comes from the quadratic formula. So I'm just going to go into some space over here. And I'm going to think about my quadratic formula. So if I have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So if we're focusing on this b squared minus 4ac part, let's think about all of our options. So our first option was if it was negative. Well, if I had x equals negative b plus or minus the square root of some negative number over 2a, well, the square root of a negative would end up getting me I. We don't work with I when we're graphing. I don't know how to graph a number that has I in it. So that tells me that we can't graph those points. So we're not going to graph it if we're not going to graph the x-intercepts if it's negative to create an I. Now the next option was, what if it's 0? Well, the square root of 0 is 0. So this would just be negative b plus or minus the square root of 0. Well, plus 0 is the same as minus 0. So this would actually end up being negative b over 2a, which is just one single number. That also, if you notice this, happens to be the vertex. So if there's only one x-intercept, then that x-intercept is the vertex of that graph. So whenever it's 0, there's only one value that actually comes out of that formula. And so there's only one x-intercept, and that is the vertex. Now next, what if it was positive? Well, if we have a positive number there, then we just have negative b plus a positive square root over 2a, and then negative b minus a positive square root over 2a. So we end up with two intercepts. So that is why that is a thing. All right. So x-intercepts, y-intercepts, and determinant are all kind of related. Now let's move on to the last part, and that is the domain and range. So the domain is all the x values that the function is defined for. In other words, that's all the x values that the function covers. So if we're thinking about a coordinate plane here, all the x values are going left to right. So we look left to right. For a quadratic graph, it's always going to be all real numbers. If we're looking at a quadratic graph, it continues going. Even though it looks like it's starting to go straight up, it is slowly inching its way outwards still. So as it goes on forever, it's going to continue going to the left forever to infinity, and to the right forever to infinity. So the farthest left point is going to be negative infinity, and the farthest right point is going to be positive infinity. So that's how we write the domain. Now the range is all the y values. So it's all the y values that the function is defined for. In other words, it's all the y values that the function covers. Well, we have two options here. Because for range, we're looking up and down since it's y values. So if I have a coordinate plane like this, and if I have a graph that goes upwards, well, my lowest point is right here. My lowest point is the vertex, and then it continues going up forever. But I might also have something like this. Well, right here, that's a highest point. My highest point is a vertex, and then it continues going down forever. Going back to this lowest point, remember the lowest point is called the minimum. And then over on the highest point, that's called the maximum. So those are our two options here. So if there's a minimum, so it has a lowest point and then goes up forever, it's going to be that lowest point, which is the vertex or the minimum. So it's the minimum point, which is the vertex, all the way up forever to infinity. But if it has a maximum, its lowest point is down forever, so its lowest point is negative infinity, and then it goes all the way up to the maximum point, or the vertex. So those are the two options there. When we're talking about the range, we're talking about the y value. So when I say the vertex, and when I say the maximum, then I'm talking about the y value of the vertex, or the y value of that maximum or minimum. All right, so let's go on and let's do some examples. So in all of the problems you're going to do for this section, what you're going to have to do is you're going to have to sketch the equation given to you. But to do this, you have all of these things that you need to determine. So first you need to determine your axis of symmetry, your vertex, which remember is basically the same thing. It crosses the axis of symmetry. You need to determine your determinant, your x-intercepts if there are any, and you can figure that out by finding that determinant. The y-intercept, two more points that are on the parabola, the domain, and the range. So let's go through and let's do this. For this first problem, I'm first just going to think to myself, a is 1/2, b is 0, and c is -3. So now when I go through an example, the first thing that I need to do is figure out my axis of symmetry. I do that by using -b over 2a. So I'm just going to plug in my numbers. I have -0 over 2 times 1/2, which is just 0. So my axis of symmetry is where x equals 0. I'm going to go ahead and go to my graph and draw this. I want to see your axis of symmetry drawn on your graph. The next thing I need to do is figure out my vertex. Well, I find out the x value of the vertex by using the -b over 2a. So I already know that the x value is 0, but that the vertex is a point. So I need to figure out what the y value is. So what I'm going to do is I'm going to plug in 0 for x to figure out what y is. So I have y equals 1/2 times 0 squared minus 3. So that's 0 minus 3, which is just -3. So the vertex is at the point 0, -3. When I come over to my graph, I'm going to go over here and graph the point 0, -3. Next, I need to figure out the determinant. I figure out the determinant by doing b squared minus 4ac. Well, my b is 0, my a is 1/2, and my c is negative 3. So this is 0 plus 6, which is 6, which is a positive number. That's the main thing we need to look at. I can't do anything more than that, but now I know that it's positive, so I'm going to have 2 x-intercepts. So to figure out those x-intercepts, which is the next part, the x-intercept is when y equals 0. So I'm going to set y equal to 0 and then solve this equation. So 0 equals 1/2 x squared minus 3. To solve this equation, I need to add 3 to both sides. And then I need to multiply by 2. 6 is equal to x squared. So I need to take the square root of both sides, and when I do that, I have plus or minus 6. Well, plus or minus rad 6, if I were to calculate that, is about plus or minus 2.45. So I've got negative 2.45 and positive 2.45. And I can go graph those. So it crosses the x-intercept at 2.45 and negative 2.45. Next, I need to figure out the y-intercept. To do that, I plug in 0 for x. And remember that we already figured out that the y-intercept is your c, so the y-intercept is negative 3. When I come over to graph that, that's already graphed because my y-intercept was the vertex, because my axis of symmetry is on the y-axis. It will not always be this way, so you need to make sure to always figure out your y-intercept, but in this scenario, it happened to work out that way. I have just a few more things left. I have a pretty good picture of what this looks like, but I need to figure out a few more points. I can't quite graph this because I don't know exactly what the curve is going to look like. So I'm going to go ahead and figure out what point is in this area here. So I'm going to go ahead and figure out what point is when x equals 1. So my question is, when x equals 1, what does y equal? Well, to figure that out, I need to plug 1 into the equation. So this is 1/2 minus 3, which is negative 2.5. So I'm going to graph that over here. When x equals 1, y equals negative 2.5. And now, since my axis of symmetry is on the y-axis, then I can mirror that point on the other side of the y-axis. If it was off of the axis, I could still mirror the point on the other side of the line of symmetry. So I know that another point is at negative 1 and negative 2.5. Now, if I looked at this and I wasn't quite sure where to graph, because maybe I don't know how my curve goes up here, then I can pick another point and I can graph one more point. So I'm going to be strategic about the number I choose, and I'm going to notice that I have a fraction, and I don't really want to deal with fractions too much, so I'm going to choose an even number for x to plug in. So I'm going to go ahead and choose 4. So I'm going to graph, or I'm going to figure out what y equals when x equals 4. Well, 4 times 4 is 16. 16 times 1/2 is 8, and 8 minus 3 is 5. So I have the point 4, 5, and I can mirror that to get the point negative 4, 5. So I'm going to graph those over here. I have the 0.45 and -4.5. Now this is a pretty good view of this, so I can go ahead and create my graph. Now remember, this is a curve. It's not going straight from one point to another. It kind of needs to curve from one point to another. And then even at the bottom, at the vertex, it's not a point. It still curves through that area. All right, I'm almost done with this problem, but I still need to figure out the domain and range. So the domain is looking left to right on this graph, and it's going to continue moving outward in both directions. So for G, the domain starts at -infinity on the left and works all the way to infinity on the right. And that's always going to be the domain for quadratic equations. Now the range, I need to look at this. I need to figure out if I have a maximum or minimum. And I have a minimum. I have a lowest point. And so looking up and down, my range is going to start from the lowest point and it's going to go up to infinity. Well, the lowest point, once again, I'm looking up and down, so I need to look at the y value. This lowest point is at -3. So my range starts at -3 and it continues up to infinity. Now I have everything completed and I have finished this problem. So go ahead and pause this video and try example 2 on your own, and then I will go through and work it, and you can double check that you got everything right. So next we're going to do example 2. So I know that my A is -1, my B is 2, and my C is -4. So first, to find my axis of symmetry, I'm going to do -b over 2a, which is -2 over 2 times -1, which is -2 over -2, which is +1. So I'm going to come over here and I'm going to put a dotted line where my axis of symmetry goes, where x equals 1. Now the next thing I need to do is find my vertex. So I know that the x value for my vertex is 1. And so now I need to figure out the y value. So I'm going to plug 1 in to this equation and figure out what this equals. So this is where it gets kind of tricky right here, because this is a -1 squared. The squared is only squaring the 1. So the negative is still there. So this is actually -1 plus 2 minus 4, which is -3. So the vertex for this is at 1, -3. The next thing I need to do is figure out my determinant. So I'm going to use b squared minus 4ac. So I have 2 squared minus 4 times -1 times -4, which is 4 minus 16. That's a -12. It's a negative, which tells me that there's no x-intercepts, so I can skip that and I can move on to part E, which is y-intercepts. So the y-intercepts is where x equals 0, and remember that when x equals 0, our y-intercept is just the c, which is -4. So my y-intercept is when y is equal to -4. Next, I'm going to pick 2 more points on the parabola. Well, I don't have a whole lot of information right now. I know that I can mirror this point right here on the other side of this x-axis, or sorry, not x-axis, on the other side of this line of symmetry. So I know that this is going to be a point, 2, -4. Now I am going to just double check that. If I plug 2 in for x, I'm just going to double check that I get -4. So if I have -2 squared plus 2 times 2 minus 4, well, -2 squared is -4, plus 4 minus 4 is 0 minus 4, which is -4. So that works. I need another one. I'm still not sure how my graph is going to look down in this area. So I'm going to go ahead and I'm going to see what this equals when x equals 4. So I'm going to plug 4 in for x. So I have y equals -4 squared plus 2 times 4 minus 4. So I have -16 plus 8 minus 4. So that's -8 minus 4, which is -12. So I have 4, -12. And when I graph that, it goes a little bit off, but I can guess that it's about down there. And then I can mirror that on the other side of this line of symmetry. So I'm 3 spots away. So I'm going to go back 3 spots, and I'm going to mirror that point over here. So now I can connect these and get my parabola that is open downwards. Now remember that we noticed that when the A is positive, it opens upwards, and when A is negative, it opens downwards. That's something that we noticed the past couple days in class when we did all the discovery stuff. And so if we check our graphs here, on example 2, the A was negative, and this opens up downwards. On example 1, the A is positive, and it opens upwards. So that's kind of a little check to make sure that our graph is looking right. So now that we know that our graph is looking right, let's go ahead and take a little bit of time and figure out our domain and range real fast. So my domain, of course, is going to be from -infinity to infinity. And my range is going to start at the maximum, because I have a maximum here. It's going to go to the maximum, and it's going to start down, because range is up and down. So we're going to start at our lowest point, which is -infinity, and it moves upwards to our maximum point, which is that vertex, and that is -3, because we're looking at the y value. So this is all that we're doing in this section. You are now able to go do the homework. Make sure you answer all of those questions about each problem and you graph it. You can either graph it as you go, so you can graph the axis of symmetry after you find it and then the vertex once you find that, or you can find all that stuff and then graph it. It doesn't matter. Whatever works for you is what you should do. Just make sure you get all of those points on there. And of course, if you have any questions, definitely come ask me, come talk to me about it.